In this example, we are going to look at stretches and compressions. To stretch something, think of it as you're multiplying it by a number to get it bigger than before. To compress, when we say compression, it would mean that you're dividing. But you need to think of dividing in multiply form. So for example, to divide by 8, think of it as the same as multiply by 1/8. You need to be comfortable with thinking of it like that because that's how we will state the transformations. Looking at this example, it appears that we have the root x function with a 5 and a 3 thrown into the equation. So my base function is y equals root x. Now let's go over the transformations. We would say that we have a vertical stretch by a factor of 5. That's basically saying that the y values are all going to get multiplied by 5. That makes sense. We have 5 times the root function, so the y values are equal to 5 times the y values of the square root function. But it's counterintuitive what we are doing horizontally. You see it says 3x, which is basically 3 over 1 times x. But when you do this as a transformation, you're going to flip this and think of it as 1 over 3x. And when you multiply something by 1 over 3, you are doing a compression. 1 over 3 times x is not a stretch, it's a compression, and that's why we say a horizontal compression by a factor of 1/3. Horizontally, it's counterintuitive. Yes, I know the equation says 3 times x, but for the key points, we're actually going to multiply them by 1/3, which is going to make them smaller, so we have to call that a compression. Here are the key points on the root x function. If you haven't memorized these, watch my video on the parent functions and make sure you know how to get these. The x values, we said we're going to horizontally compress them by a factor of 1/3, meaning that the x's are multiplied by 1/3. So let's go ahead and do that. 1 over 3 times 0, 1 over 3 times 1, and 1 over 3 times 4 is 4 over 3, which in decimal form is 1.33. Y values, right after the equal sign, we see a 5, so the function y values are going to be 5 times as big, 5y. 5 times 0, 1 times the 5, and then 5 times the 2 is a 10. So these are our key points, which we're going to plot. Let's make a scale, and then we'll plot these and connect them. So here's our scale. I spaced out the x values much more than the y's, just because I saw that these are very small, they're not too far apart, and to make it easier to graph, that's why I did that. First key point, 0, 0. Second key point, 1/3. So 1/3 of the way towards 1, right around here, with a 5. Then 1.33, 4/3, which is 1 and 1/3, somewhere here. And that's going to be plotted with a 10, right there. And then I can connect these. But I also like to know where is my starting point. On the square root function, the starting point is 0, 0. And the rest of the key points are to the right of it. So there's a graph only on one side of a key point 0, 0 for the square root function. You don't have a graph that goes both ways, like down here. That's like the wrong way to do it. You have the 0, 0, and the rest of the key points are on one side. So I gotta make sure that I do that with this new graph. 0, 0 hasn't moved. So this is my starting key point. The other two key points are to the right of it. So I just connect and the graph goes on there forever. There is no graph going downwards here. That's a common mistake I see. Okay, now that you've done this, if you're able to follow, You can try question B on your own, and if not, just watch me walk you through. Give it a try. Okay, let's work out question B. Again, this looks like some kind of manipulation, modification of the square root function. So this is going to be our base function. This is the one where we get our key points from. It doesn't look like anything else, right? Doesn't look like any of these parent functions I discussed before. So let's go with the square root function. Transformations. Right after the equal sign, we have a quarter. So you can kind of sense that maybe you're going to make the y value smaller. Question A, we had 5 there. And the 5 meant that we are multiplying the y values by 5. So now we are going to multiply the y values by a quarter. And when you do that, they get smaller. And that's why we're going to call it a compression. Question A, we had the 3, which is like 3 over 1, x. But we said that the x values got multiplied by a third. We flipped 3 over 1 to 1/3. And that's what we're going to do with the 1/2. If you flip 1/2, it becomes 2 over 1. So now we're going to multiply the x values by 2 over 1, which is going to make them larger. So we are going to call that a stretch. So here's how you write it. A vertical compression by a factor of 1/4, but it's a horizontal stretch by a factor of 2. Horizontally, it's always going to be counterintuitive. When you see a half, you flip it, and that's what you multiply by your x values, so they get bigger. In the vocabulary, we say it's stretchy. To stretch means to make something bigger. To compress means to make it smaller. Key points on the root x function, and then we're going to use the mapping rule. The x values. We said that the x values are actually going to get multiplied by 2 over 1. So I'm going to write 2 over 1x. You could also just write a 2x if you want. The y values, we said that they are going to get multiplied by a quarter. So I write 1/4 y. 2 times all of my x's, 0, 2, 2 times 4 is 8. Y values, multiply them all by a quarter. 2 times a quarter is 1/2. Let's make a scale and connect these points. Okay, here's a scale. Looking at the x's are far apart, so I went with a scale of going up by ones. The y values, they're very small. I didn't want the graph to look too compressed, so I spaced them out just for visual purposes. Every 2 square is a 1. 0, 0, 2 with a quarter, so a quarter would be here, and then 8 with a half. Okay, and now I'm going to connect these, but again, I would like to know where's the starting point. The starting point on the root x function is 0, 0. And for us, it's still at the same point. So we are going to have this as our starting point. That means the graph is not on both sides of it, on just one side of the origin. And if I connect these points, now I know that the graph is only going to show up to the right of the origin. For those of you that don't know what I'm talking about, I've seen a lot of students just do that and basically show a graph on both sides of the key point 0, 0, but that's not the case with our square root function. It has a beginning, and the way you know this is the beginning is the other 2 key points were to the right of it.